Okay, ladies and gentlemen of geometry, this is section 3.5, isosceles and equilateral triangles. All right, isosceles and equilateral triangles are very special, very specific triangles. Okay, and here's what isosceles triangles boils down to. All right, isosceles triangle, remember, has got two sides that are equal. Now, in that situation, if I've got two sides that are equal to each other, if I've got an isosceles triangle, what I can then say is that the opposite angles are congruent to each other. So if these two are my congruent sides, the opposite angles are also congruent to each other. Okay, that works backwards and forwards. Okay, if I can say this, then I can say this, but then I can also flip it around. If I have this is true, I can also say it's isosceles. All right, and that's kind of what this is saying. This is saying if I've got angle 1 congruent to angle 2, then I can also say, you know what? DE is also going to be congruent to FE. So that's going to be how that works. So if I look here, this is 120 degrees, angle N, but that's not really important to me. What is important to me is the fact that these two are congruent to each other. Because those two are congruent to each other, that means the opposite sides are congruent to each other. So that's 11. All right, so that's going to be your answer. So if I say find the value of z, well, I got to make sure I set this one up to whichever one is equal to. So s and t are congruent to each other. It's got to be the opposite side. So I got to take 2z minus 15 equal to 9. All right, most kids that mess this up will set this equal to 7. They'll just say, hey, let's set these two equal to each other. No, I've got to look at what's the relationship between the angles and the sides. So I've got to look here, go across, go across. That's the relationship right there. So little algebra, add 15, zeros out, 2z equals 24, so z should equal 12. So, little proof here. So you're given LM is congruent to LP. So somehow you have to prove that M is congruent to P. So here's what I'm going to do, is I'm going to prove that angle M is congruent to angle P. So I'm probably going to use the side, 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 or side, or angle, or any of those that we've talked about. And then once I've proved the two triangles congruent, I'm probably going to say angle M is congruent to angle P for the reason of CPCTC. All right, so how do I start every proof? Start with your given statement. So LM is congruent to LP, and that's given. Second statement I'm going to say is that angle LN is congruent to angle LN. And why are you congruent to yourself? Why the reflexive property, of course. So now, here's what I'm going to look at. Okay, not only is LN part of both triangles, so here's what I'm going to say. LN is perpendicular to MP, okay? And I know that because LN is what's called a perpendicular bisector. That means two things. That means it's perpendicular and it's a bisector, so that means it cuts these into two equal pieces. So now I got a couple different ways I can go. I can say, you know what, if it's a perpendicular bisector, I'm going to say MN is congruent to PN by definition of bisector. So then I can say, you know what, yeah, those two triangles are congruent to each other. MLN congruent to PLN by side, side, side. Then my final statement is going to be what I'm trying to prove. Angle M congruent to angle P by CPCTC. Okay, so that's how I would do that proof. Sorry, I kind of jumped ahead there. So that's how you can prove kind of the triangle, isosceles triangle theorem. So equilateral triangle. In any equilateral triangle, all three are equal to each other. Triangles got to add up to 180. So if I've got three of the same angle has to equal 180, that means every angle's got to be 60 degrees. So a triangle is equilateral if and only if it is equiangular. That means if every angle is 60 degrees, every side is congruent. If every side is congruent, every angle is 60 degrees. So this is 60. All right, this is 5, this is 5. Guess what? This is an isosceles triangle. I know because these two are congruent. That means these two angles are congruent to each other. Well, if this is 60, these two got to be congruent. So that's like 2 times x plus 60 equals 180. So a little algebra. X is going to be 60. That means this is 60, this is 60. But wait, all three are 60. That means it's also got to be equilateral and equiangular. So that means if this is 5, this is 5, this third segment right here has also got to be 5. So be careful just because of what it looks like. All right, so now take a look here. You've got 4x minus 8 and 4x minus 8, but it tells you these two sides are congruent to each other. It tells you that. All right, so solving for y is easy. This is going to be equal to this. So I say 6y plus 3 equals 8y minus 5. All right, so a little subtraction. You've done this before. Hopefully your algebra game is strong. So y is going to equal 4. Now, x is a little bit different. Okay, now you got to look back at the triangle here. All right, so these two sides are equal to each other. But if you look, this angle and this angle are equal to each other. That is different than the angles that are supposed to be congruent to each other when you have an isosceles triangle, though. Isosceles triangle says, hey, these two sides are congruent. That means the opposite angles are congruent. That means if angle E is 4x minus 8, then angle D is also 4x minus 8. But wait a second. I've got all 4 angles equal to 4x minus 8. That's weird. Or the other situation is this. This is really an equilateral triangle in disguise. Okay, it's just kind of hiding a little bit. So all 3 of these are 4x minus 8. That means any one of them has to equal 60 degrees. So 4x equals 68 divided by 4 divided by 4. Little mental math. It's 1. 28 is going to be 17. So x is going to be 17. So if I take a look at this one, this is kind of that same situation. All right, those two sides are congruent. That implies the opposite angles are congruent. So this one's 2x. This one's also 2x. Now I've got all 3 are 2x. So this is really an equilateral in disguise. So that means any angle is going to equal 60. This should take you about 2 seconds to realize that x is going to be 30. Sorry, x is going to be 30, not 30 degrees. 2x is going to equal 60 degrees. So if it's equilateral, then all 3 sides are the same length. So this is 3, this is 3, this whole thing equals 3. So 4y minus 5 equals 3. So 4y is going to equal 8. And y equals 2 should jump out at you. So take a look at this guy for a second. This one is not a equilateral in disguise. Okay? Here's why. Those two are equal to each other. Okay? So 4y minus 2 equals 2y plus 2. This implies that this and this are equal to each other. So this is 6x plus 8, so this one also has to be 6x plus 8. There is nothing to say that either one of these two angles are equal to this one. All right, that's why I can only say these two are isosceles. All right, this triangle's isosceles. Those only 2 sides are congruent. I'm not trying to hide a third angle that's congruent to the other 2. So when I solve this, those 2 sides are equal to each other, so this just becomes a matter of doing a little algebra. So 2y equals 4, so y is going to equal 2. Now, here's where I got to start thinking a little bit. All right, I got to think whole triangle here. Let's change colors. Whole triangle's got to add to 180. That means 6x plus 8 plus 6x plus 8 plus 80 has got to equal 180. All right, all I did was say, here's the first angle, here's the second angle, here's the third angle. I'm putting it all together, and it's got to equal 80. From there, I can figure out what x is. So this becomes 12x plus 16 plus 80 equals 100. Sorry, I should put these two together. 12x plus 96 equals 180. Sorry, that's an 80. So now subtract 96 from both sides. That becomes 0. 12x becomes 84. Little division. So x should equal 7. So x is going to be 7. All right, thank you very much for playing. Look over this video as much as you need to. Please watch it and fill out the notes. And I will talk to you in class. Thank you very much.